Welcome, Highlanders, to the review session for the final exam for Econ 143, or our environmental economics class. This exam is going to focus on all the newest material since the midterm exam, or chapters 5, 6, 7, and 8. If you're interested in reviewing that information from chapters 1 through 4, then I encourage you to check out that midterm exam review session. Those recordings have been posted for you. But again, the exam will cover everything, so chapters 1 through 8, or everything from the beginning of class, will consist of short answer, mathematical, and graphical questions. Pretty similar to the types of questions you've seen on your homework assignments, your midterm exam, any examples that we've done in class, and your thought-provoking weekly assignment questions. So there won't really be too many surprises on there as far as the kinds of questions you can expect. Again, be pretty similar in format to the types of assignments you've completed so far, and you'll complete it in the same kind of way through iLearn. Right. As far as our suggestions for studying is concerned, I go through your class notes first. I posted a study guide out there to help you organize your studying. And then I would go back through the homework problems, the thought-provoking assignment questions, maybe your midterm exam if you like, to make sure you know how to answer similar questions. Right. Again, the questions asked on this final exam won't be the exact same, but they might be similar with maybe just the numbers changed, or pretty similar again to the types of questions I've already asked. And go through these review session PowerPoint slides and watch this video for additional practice and examples. We're going to go through some examples of questions that, again, are going to be pretty similar to the types of questions you might see on the exam. Right, so consult the videos or let me know if you have any questions at all. I'll be happy to answer any questions that you may have if, again, there's still something you understand after doing all that review. So with that in mind, let's go ahead and kick it off with Chapter 5. So in Chapter 5, remember the big mathematical issue there was being able to find the socially efficient level of emissions, what was known as the optimal level of pollution, when given a set of equations, those equations referring to the marginal damage costs and the marginal abatement costs. Remember, you set those two equations equal to one another, and then we can, in order to find that optimal level of emissions and the cost at the optimal level of emissions. And then you can calculate total damage costs as the area under the marginal damage cost curve. Remember, total abatement cost is the area under the marginal abatement cost curve. Total pollution cost is just your total damage cost plus your total abatement cost, or adding your two costs together. So with that in mind, if you get a question like this that says, suppose that Sly Sludge's Waste Management Corporation has the following marginal damage costs and marginal abatement cost curves, I give those to you there, right? Again, be able to go through those steps in order to calculate out what we just talked about. So let's go through an example and make sure that we can do that. So I'm going to go ahead and exit the full screen mode. It's just easier to write with this pen in this mode here. Right, so again, we have these two equations. So you can go ahead and start drawing out your graph if you like, based on what those two equations are showing you. So again, up here we're representing costs, and down here we are representing those emissions, or E. All right, remember you have a marginal damage cost curve that's sloping upward. When emissions is 0, our marginal damage costs are 0. All right, so that's what your marginal damage cost curve looks like. Now, where does your marginal abatement cost curve start, or where does it hit that y-axis? Right, well, again, in order to figure that out, you got to set emissions to 0. So when E is equal to 0, we know that our marginal abatement cost is equal to 300, right? So we can start that right here at 300. Right. And again, this curve is probably going to be a little bit flatter than your marginal damage cost curve, simply because the magnitude of its slope seems to be a little bit smaller. Maybe hitting the x-axis somewhere around there. We can actually figure out where it hits that x-axis by setting MAC equal to 0 and solving for E. If you do that, 2E is going to be equal to 300, or E is going to be equal to 150. Remember, that is the maximum amount of emissions, right, that this firm is going to create if unregulated. And then we can, again, solve for this equilibrium here, the optimal amount of emissions, and figure out what the costs are at that optimal level of emissions simply by setting these two equations equal to one another. So let's go ahead and do that. So again, we're just setting our MDC curve equal to our MAC curve. So we've got 3E equal to 300 minus 2e, right? So we can bring that 2e to the other side. So we got 5e is equal to 300. So that means that our E star is going to be equal to 60. So 60 is our optimal amount of emissions. Put 60 there. Again, that is our E star. Okay. Now, in order to figure out what the cost is at the optimal emissions, then we just plug that 60 into our two cost curves here, right? So we got marginal abatement cost, again, at E equals 60. Looks like this. We got 300 minus 2 times 60, or 300 minus 120 is 180. We got marginal damage cost, again, at E equals 60 is just 3 times 60, which if you did it right, it should be the same number, 180. So again, 180 is where we hit that equilibrium cost, right? So in other words, the marginal cost of abating another emission is 180. The marginal cost of having another emission is 180, right? Now remember, the next thing I told you might have to do is figure out what are the total damage costs and the total abatement costs when we are at this optimal amount of emissions, right? Remember that total damage cost is the area under your marginal damage cost curve, right? So again, our total damage costs represented here. And our total abatement cost is the area under our marginal abatement cost curve, which is this curve here. So this is going to be our total abatement cost here, right? And so we can calculate that out. So if you want to calculate out our total damage costs, remember that's just the area of that triangle, which is 1/2 base times height. The base of that triangle is 60 minus 0, or 60. And the height of that triangle is that 180, the cost at the optimal level of emissions. Right, so that's 1/2 of 60 times 180. That's going to be equal to 5,400. Now, total abatement cost is just the area of that triangle, and so that'll be 1/2 of that max number of emissions, 150, minus 60. That's going to be the base of that triangle, right? That's going to be equal to 90 times 180. And 90 times 180 is 8,100. So now our total pollution costs are just those two added together. So that's going to be equal to 13,500. Right, so that's kind of the first example of something you might have to do on the exam with regards to the new material anyway, and that is calculate that optimal level of emissions, the cost at that optimal level of emissions, and then figure out total damage costs and total abatement costs, and then finally total pollution costs by adding your damage costs and your abatement costs together. So that's number one here in our examples calculated out for you. So make sure you can do that on the test. Again, in case you get a problem like that, which you certainly might. Kind of gone over that a lot, so, and we'll go over it a little bit more. So you might want to expect a problem like that on the exam. All right. So moving forward here, you also need to be able to use the equal marginal principle to figure out how many emissions to come from each source of pollution for a company that is trying to minimize costs. Also, make sure you know how enforcement costs will raise the marginal abatement cost for a company, and how technology will lower the marginal abatement cost for a company, and how either of these could affect the optimal rate of pollution, as well as the damage costs, abatement costs, and pollution costs for a firm. Right, so with that in mind, let's go ahead and take a look at a few examples to make sure that we can figure that out. So example 2 says, suppose that Sly Sludge can operate his company by either burning coal or oil to run his corporation. Each of these has the following marginal abatement costs. So the marginal abatement cost for coal is 100 minus 4 times the emissions of coal. And then the marginal abatement cost for oil is 200 minus 6 times the emissions for oil, or that E sub O. Write out your efficiency constraint. Remember that marginal abatement cost has to be equal for coal has to be equal to the marginal abatement cost for oil. And the abatement constraint, which is that our total emissions from coal and oil added together, has to equal 60. So our emissions from coal is equal to 60 minus our emissions from oil. If you're wondering where that 60 comes from, we just calculated it here in the last problem, right? Remember, this was also concerning Sly Sledge's company, and we decided the optimal level of emissions was 60, right? So this problem is just asking you to figure out, now where are those 60 emissions going to come from, coal or oil, if Sly Sludge is trying to minimize his costs, right? Let's go through an example on how to figure that out. So what I've done here is I've kind of written these two equations, right? Again, right here, just to make sure that you can see them as we're going through this problem. And remember, we also have this constraint of E0 plus E sub C, sorry, E sub O plus E sub C is equal to 60, which is the same thing as saying that E sub C is equal to 60 minus E sub O, just by moving that E sub O over to the other side. All right, once you've got that set up, then you can go ahead and start setting these two equations equal to one another. So you got 100 minus 4 E sub C is equal to 200 minus 6 E sub O. And now all we're going to do is we're going to plug this E sub C into this equation here in an effort to make sure that we just have one equation with one unknown. Right, so this is going to be 100 minus 4, and then we're going to plug in that 60 minus E sub O equal to 200 minus 6 E sub O. Okay, now all we got to do is math that through. So we got 100, and then we got negative 4 times 60, so this will be minus 240. And then we got negative 4 times negative E sub O. Don't forget to distribute that negative sign through. So this is going to be plus 4 E sub O. And this is again just 200 minus 6 E sub O. So now we're going to add that 6 E sub O to the other side. So we got 10 E sub O is going to be equal to, and this is negative 140 here that we are now going to move over to the other side. So that's 10 E sub O is equal to 340. All right. So again, 100 minus 240 is negative 140. And in order to get rid of that, we got to add that to the other side, right? That's where that 200 plus 140 gives us 340. All right, now we just got to divide both sides by 10, which means that E sub O star, if you will, is going to be equal to 34, right? And remember that E sub C star is going to be equal to 60 minus that E sub O star, which means that E sub C star is going to be equal to 26. We go. All right. So again, we know that 34 of these emissions should come from oil and 26 of these emissions should come from coal if we're using the equal marginal principle in order to minimize costs, right? So again, just make sure that you can plug this equation here into this formula here, and in doing so, I think it's pretty easy to calculate out from there. That's just the key step to remember. And again, where does that equation come from? Well, from the optimal level of emissions we found out, or we solved in problem 1 there. So again, this is our problem 2. All right. So another example that you might run into on the exam might look something like this. Suppose an enhancement in technology lowered abatement costs by 100. How will this affect Sly Sludge's optimal level of emissions and total pollution costs? Now remember, if we're talking about an enhancement in technology that lowers the abatement cost by 100, then that's going to subtract from your marginal abatement cost curve. So you subtract the value of the technological improvements from the marginal abatement cost curve, right? So again, this is going to subtract from your marginal abatement cost rather than add to it. So that's the key component here. And then from that, you just calculate things the way that you've always done. You set the marginal damage cost equal to the marginal abatement cost and calculate out your total damage costs, your total abatement costs, and your total pollution costs in the same way that you did before, right? So let's go through that example just to make sure that we can do that in case you get that on the exam. So we'll call this example number 3 here. We'll go ahead and do this one in blue. So again, remember that our marginal abatement cost curve is now going to be adjusted for technology. So we'll call it MAC sub T. and that's going to be equal to 300 minus 2e minus 100. Remember that technology is going to make those abatement costs cheaper, right? So again, this is just going to be equal to 200 minus 2e, all right? So again, if we're graphing this out, you know that if we set e equal to 0, this is going to start here at 200. And you're going to have a marginal abatement cost curve that might look something like this, right? And this is going to be, again, if we want to figure out exactly where that's going to hit the x-axis, then we set that MAC sub t equal to 0, and that's what this curve here represents, and solve for e. And when you do that, then you should get 100. All right, so this is E max sub t. All right, so again, hopefully, again, just doing the same thing that we did with number 1 here with number 3, you can figure out where to draw that curve and where it's going to hit those x-axes. All right, again, if you were confused on that, all we did was we set E equal to 0 to figure out that MAC sub t was going to hit at 200, and then we set MAC sub t equal to 0 to figure out that E max was going to be 100. Right. All right. So with that in mind, let's go ahead and solve for this new equilibrium. So again, we're going to have a new equilibrium number of emissions. So again, this will be E star sub t, right? And then we're going to have a new cost associated with that, right? And we can go ahead and calculate this out, right, by just setting those two equations equal to one another once again. So we got 3e equal to, now it's 200 minus 2e as we set that MDC equal to our MAC sub t curve. Right, so again, we add the 2e over to the other side, so we got 5e is equal to 200. So we know that E star sub t is going to be equal to 40. So again, 40 is what we got over here. Now all we got to do is plug that 40 into either or both equations, and you should be able to get the same number that represents the cost at that number of emissions. So our MDC equation, again, at E star sub t is equal to 40, is going to look like 3 times 40, which is equal to 120. And then our MAC sub t equation at E sub t star being equal to 40 is going to be 200 minus 2 times 40, or 200 minus 80, which is also equal to 120. Right? Okay, and again, we can figure out our total damage cost as the area under the marginal damage cost curve, right? And then we can figure out our total abatement cost as the area under our marginal abatement cost curve when we use that marginal abatement cost sub t curve, right? In other words, this is going to look like our total damage cost here, and this is going to be our total abatement cost here, right, at this new equilibrium. So we can go ahead and calculate those out if we'd like to see how they've changed compared to what they were before. So our total damage cost is equal to 1/2, and we need the base of that triangle, which is 40 minus 0, times the height of that triangle, which is 120. So that's going to be 1/2 of 40 times 120, which is going to be equal to 2,400. And then our total abatement cost is the area under that marginal abatement cost curve at this new equilibrium. And so that's going to be 1/2 of 100 minus 40, or 60, times that height of 120. Right, so 1/2 of 60 times 120 is 3,600. And so your total pollution costs at this new equilibrium is equal to 6,000. Notice that 6,000 is remarkably cheaper than the 13,500 that our total pollution cost represented when we didn't have this technology in place. So technology lowered those costs by $7,500. Now, will firms adopt this new technology? Well, it depends on how much that technology costs, right? We got to compare that cost to the $7,500 that was saved as a result of employing this technology, right? With that in mind, do notice that again, it reduced both the damage cost because you have less emissions, as well as the abatement cost because it was cheaper to abate emissions with this new technology in place, right? All right, so again, that's answering this question over here, number 3, right? Now, with that in mind, remember, technology subtracts from our marginal abatement costs, right? But the cost of enforcement will add to our marginal abatement costs. So problem number 4 here says, suppose the cost of enforcing this abatement is $100. How would this affect Slide Sludge's optimal level of emissions and total pollution costs? And the big difference here is that whereas, again, technology subtracted from marginal abatement costs, again, our enforcement costs are going to be adding to our marginal abatement costs, right? And then once you do that, then you solve it in the same way that we've been doing. You set the damage cost equal to your new marginal abatement cost curve. You calculate out the damage cost, the abatement cost, and the pollution cost, right? So if you want to see what that looks like, then we can go ahead and graph that out. If you're already familiar with maybe how to do that, then you can skip ahead in the video if you prefer. But I'm going to do it one more time for anybody who's curious, right? So this will be number 4 here, which we'll do in red, right? And now we're going to have a marginal abatement cost, call that sub E, which is going to be equal to our original 300 minus 2E, but now we're going to add to that 100 as opposed to subtract from it. And that's going to give us 400 minus 2E. Now, again, we're just applying these enforcement costs to our original marginal abatement cost curve. If we were to apply those enforcement costs to our MAC sub T curve, so say we had both technology and enforcement at the same time, then that minus 100 and that plus 100 would cancel out. You'd be right back to your original marginal abatement cost curve, right? But again, if we wanted to figure out where this is going to hit the y-axis, then we just got to set E equal to 0. If you do that, then MAC sub E, which represents those enforcement costs, will equal 400. And then if you want to figure out where it's going to hit the x-axis, then you just set MAC sub E equal to 0, and you solve for that maximum number of emissions, and that looks like that's going to be 200. Right? So you have a marginal abatement cost curve that's going to look something like this. So again, this is our MAC sub E, right? Again, it's going to be 400 here on the y-axis, and it's going to hit right here at 200. This is going to be your Emax sub E. All right, so we've got a new equilibrium that we need to now calculate, right? Which means that we need a new optimal number of emissions, E star sub E, if you will. All right, so in order to do that, same process, we set our MDC equal to now our MAC sub E curve, which gives us 3E equal to 400 minus 2E. You can add that negative 2E over to the left side, so we got 5E is equal to 400. So we know that our E star sub E is going to be equal to 400 divided by 5, which is 80. Right, so 80 is what our E star sub E is. Again, we can plug that into either or both of our original equations in order to figure out what the cost is here. This is at E star sub E is equal to 80, right? So that's going to be equal to 3 times 80, which is equal to 240. And then MAC sub E at E star sub E equal to 80. should be equal to 400 minus 2 times 80, which is also equal to 240, right? So 240 is what our costs are, right? So we go up here to this curve. It's going to be somewhere in here. Pretend I drew this to scale, and we'll say that our 240 is right there, right? Okay, so with that in mind, we can go ahead and calculate out those damage costs and those abatement costs and those pollution costs one more time if we so desire. So our total damage costs is now the area under our marginal damage cost curve at this new equilibrium here, right? So again, if we're calculating that out, then it's going to be the area of this triangle here. So if we're calculating out those total damage costs, then that is going to be equal to 1/2 times the base of that triangle, which is 80 minus 0, times the height of that triangle, which is 240. So 1/2 of 80 times 240 is equal to 9,600. Right. The total abatement cost is equal to 1/2 times the difference between 200 minus 80, or 120, times that 240. And if you're looking for where I got those dimensions, then it's just the area under your marginal abatement cost sub E curve, or it's the area of this triangle here. So the base of that triangle is at 200 minus 80, or 120, right, times that height of that triangle, which is 240. All right, so that should be equal to, I believe, 14,400. And that means that our total pollution costs is just equal to those two numbers added together, right, which should be 24,000. So you notice that relative to when we didn't have any technology or enforcement costs, these enforcement costs are going to considerably add to our pollution costs, right? They're going to add to both our damage costs because they're going to increase the optimal number of emissions. So you have more emissions happening, which are damaging the environment. And of course, it's going to add to our abatement costs because now there's this enforcement that you must do to make sure that firms are abating these emissions. And that's going to be costly to both the public if taxpayers are paying for it, and both the private sector if private companies have to keep track of this stuff or keep those records, right? So with that in mind, that's how you do that particular example there. So notice that we have now covered how to figure out the optimal number of emissions, the cost of that number of emissions, total damage costs, total abatement costs, and total pollution costs 3 different times here as part of these examples. So again, it's a pretty good bet that it's going to be on the test. So make sure you know how to do it should it appear on the exam. And that is what Chapter 5 was all about. So if you can do that stuff, then you should be okay for that chapter. Now, Chapter 6 talks about the advantages and disadvantages of centralized policy, right? Again, as compared to decentralized policy. So when it comes to decentralized policy, some advantages are that if you assume appropriate setup, there are a limited amount of enforcement costs. In other words, it is something that's pretty easy to enforce because people kind of do it on their own, right? And we just talked about how those enforcement costs can ramp up that optimal number of emissions and the cost caused by that pollution. Remember that the parties involved who are directly impacted can determine the damage costs. So in other words, it's the people who are directly experiencing this pollution who can determine how much this pollution is damaging their lives. And because it is the people who are directly experiencing this problem who are out there trying to find a solution, there's a strong incentive for them to find that optimal solution. Now, some disadvantages of this decentralized policy is that appropriate setup means that you have to have a small number of parties and or low negotiation costs. to engage in that kind of stuff like coast bargaining, which we talked about in Chapter 4, and is a reason you might want to review that old material. Now, that small number of parties and low negotiation costs is a pretty big assumption. That's not something that often happens when we talk about environmental damage. So again, if you don't have this appropriate setup in place, then this decentralized policy where people can work stuff out for themselves without the government getting involved might not exist as much, right? The socially optimal solution might still not satisfy those who have a more moralistic approach to environmentalism. Is another disadvantage, right? Just because the people involved work out a solution that works for them doesn't mean that some extreme environmental group somewhere else is going to be happy with that particular solution, right? In reality, they might still be dissatisfied because whatever the solution was, it might not reach what they think is the desired amount of environmental quality. Right. So again, there are some disadvantages to having this decentralized policy in place as well. Right. Now, with that in mind, please know the sources of market failure and the potential solutions that the government uses to overcome that market failure. So we talked about how lack of competition and natural monopolies could be a problem for the market. Right. When it comes to a lack of competition, remember that if there aren't firms out there to compete, and there's only, say, maybe one company that is out there producing everything, then they might not produce the efficient quantity. In fact, they have incentive to hold back quantity in an effort to jack up the price, right? And so that's why the government has these antitrust laws and regulations in place that prevent companies from acting like a single monopoly, right? Remember that a natural monopoly is a situation where the fixed costs of setting up the industry might be really high, but the marginal costs of adding another customer are really low, so it's going to have economies of scale all the way throughout production, right? So it might be like we're talking about the water companies setting up all the water pipes throughout the entire city. That's a huge fixed cost, but then all you got to do when you move into a new place that already has the water pipes attached is just call them up and say, hey, turn on my water, put it in my name, and you're good to go, right? So the problem with these natural monopolies is that it's going to be very difficult for another firm to get into the industry and compete with those that are already there with a lot of customers, because the more customers you have, the lower your average cost will be, right? So with that in mind, it might be necessary to just have one provider in this market. If you're only going to have one provider or monopoly in this market, then maybe it should be the government, right? So that is the idea behind how a government might be able to solve that particular problem. Lack of information is another source of market failure. Remember, the government can try to solve that through regulation and enforcement, right? So again, there are regulations in place that kind of force companies to provide a certain amount of information to their consumers. We talked about the Food and Drug Administration forces companies to figure out what mixes of drugs are safe, right? Whether or not it should or should not be taken with food. All these things that people wouldn't necessarily be able to figure out on their own. Right, so again, it has to pass through those FDA tests in order to get to the market. Now, a quick side effect of that might be the fact that if there's only one enforcement company like the FDA in place, then that company does not have the incentive to operate particularly efficiently, which is why, again, it takes usually an average of around 11 years and hundreds of millions of dollars to get a drug approved and into the marketplace, right? Talking about externalities back in Chapter 4. Remember, you have negative externalities or the external negative effect on other individuals. The government can try to solve that through Pigouvian taxes. We also talked about positive externalities or that positive external benefit that your action can have on other individuals. And the government will try to ensure a efficient amount of those through Pigouvian subsidies. Right. So again, you want to provide, you want to use Pigouvian taxes to attack those negative externalities because the market will produce too much. And if we put those taxes in place, then we're going to have less of this out there, right? Whereas with the example of positive externalities, the market doesn't produce enough. So we want to make sure there's more out there by using those Pigouvian subsidies, right? Remember, the Pigouvian tax is a tax in the amount equal to the marginal external cost being created. Pigouvian subsidy is a subsidy in the amount of the external marginal benefit being created, and it's hard for the government to know exactly what that amount is. And then finally, public goods are goods that are non-rival in consumption and non-excludable. That means multiple people can use the good at the same time. One person using it doesn't interfere with somebody else using it. And also, non-excludable means that it's impossible or at least incredibly costly to exclude a non-paying customer from using that good. Right, so one way that the government can overcome this problem is by forcing people to pay for it through taxes and then providing it like we do with national defense. although remember, it's still hard for the government to know exactly what that right amount is, and the market can provide it by tying public goods to private goods. This is all stuff that kind of we learned way back in chapter 4, right? So that's kind of the example of the market failure and the potential solutions that the government can use to overcome that market failure. So again, remember, wherever there's markets, there tends to be market failure, and wherever there's market failure, there is a room or a role for government solutions, right? However, wherever there are government solutions, there are also government failure. So know that what the sources of government failure are, and the fact that government failure represents the inefficiency that results from the ways that government officials make decisions when interacting with the economy. And so again, you just got to decide, is that overcoming that market failure worth all that government failure you're going to deal with? Remember, the government failure includes the lack of profit motive that the government faces. They do not have the incentive to operate efficiently or keep costs down or keep customers happy. That's why you're probably going to have a worse customer service experience at the DMV than you would at, say, Walmart or Target. Right? Remember, the government also suffers from what's known as the short-sightedness effect. This is the issue where governments tend to favor programs that have immediate visible benefits, even if the costs outweigh those benefits, so long as those costs are way out into the future or hard to identify. Right? Again, it's the politicians saying, we'll let the next person worry about paying for it. And again, if it never gets paid for, then that's how you end up $25 trillion plus in debt, like our country currently is. And then you also have rent-seeking, which is lobbying. The problem with that rent-seeking or lobbying behavior is every dollar, hour, or ounce of effort that is spent lobbying the government for special favors is a dollar, hour, or ounce of effort that is not spent making products faster, better, cheaper, or more environmentally friendly. And then you have the special interest effect. That is when politicians tend to favor programs that offer benefits to a small, concentrated group of people. Again, even if the costs outweigh the benefits, so long as those costs are widespread among everybody, like an unorganized group of taxpayers, right? And unfortunately, that special interest effect encourages that kind of lobbying behavior, or what we know as crony capitalism, where businesses might receive special favors from the government in exchange for things like campaign contributions, and that creates an uneven playing field or reduces that competition. And a lack of competition is one of those market failures that the government's supposed to solve, not create. Right. So again, remember that stuff that we talked about in Chapter 6 with regards to government failure. Right. So again, there's not perfection anywhere. It's either market failure or government failure. You got to decide what kind of failure you'd rather deal with when deciding whether or not these policies should be in place. All right. So with that in mind, be able to figure out an effluent tax on emissions and how that affects a firm's level of emissions in the case of one or multiple firms. So starting off with one firm, just set the marginal abatement cost curve for that firm equal to the tax in order to get the optimal level of emissions, and then be able to calculate the tax revenue or tax cost to the firm at the optimal level of emissions. Remember, the tax cost to the firm is the same as the tax revenue collected by the government, right? It's the same number. Wherever the firm pays the government, the firm would refer to it as a tax cost. The government would refer to it as tax revenue. Be able to calculate the total cost of the firm, which is just your tax cost plus your abatement cost, and then know why the optimal level of emissions is optimal for the firm. What would happen if emissions were higher or lower? And the quick answer to that is that costs would be higher. Right? So again, the optimal level of emissions is the level of emissions that does minimize those costs or keep those costs low. So again, be able to do an example like this. Let's say Loot and Plunder, another Captain Planet character, runs a business that has a marginal abatement cost of 240 minus 6E, and then Captain Planet and the Planeteers have convinced the government to institute a $60 effluent tax per emission. Right, so every time the firm emits say a ton of pollution into the atmosphere, they have to pay that $60 tax. Right, so remember, you want to set the marginal abatement cost curve equal to the tax to get the optimal level of emissions, and then be able to calculate the tax revenue, be able to calculate that total cost, and know why the optimal level of emissions is indeed optimal. Right, with that in mind, let's go ahead and go through this example, right, and take a look at the optimal emissions under an effluent tax for one firm. So once again, I'm going to exit the full screen mode so that we can draw this more easily and go ahead and set up this problem. Okay, so let's go ahead and draw out our graph here. So we're going to have a vertical axis and a horizontal axis. The vertical axis, we're going to be measuring dollars. And on the horizontal axis, we're going to be measuring those emissions. Right, so remember, we're going to have a marginal abatement cost curve that slopes looking something like this, downwards from left to right. Now, that marginal abatement cost curve, we can figure out where that's going to hit the y-axis by setting that e equal to 0. We know that our marginal abatement cost is equal to 240, right? And then we can figure out where it's going to hit the x-axis by setting our marginal abatement cost equal to 0 and solving for E, and that looks like it's going to hit right there at 40 emissions. So again, that would be the maximum number of emissions if this was unregulated. All right, and then we also have an effluent tax curve that is just a straight, flat, horizontal line right there at 60. Maybe looking something like this. So again, that's going to represent our tax, and that's happening right there at $60. So of course there's an equilibrium where those two curves intersect. Right, it's going to give us our E star in light of this tax, and we need to figure out where that's going to be. So you just got to set your marginal abatement cost curve equal to the effluent tax, right? So in other words, we've got 60 equal to 240 minus 6E. Move that 6E to the other side, subtract both sides by 60, and we've got 6E is equal to 180. So we know that our E star is equal to 30, right? So that's going to be our optimal number of emissions, right? Now, from there, it's pretty easy to figure out what your tax cost is, right? So your tax cost is just this, here, this box here, $60 per emission, times the number of emissions, which is 30, right? So that's going to be how much we pay in taxes. And then the abatement cost is going to be the total abatement cost is going to be the area under your marginal abatement cost curve at the optimal number of emissions. Or this triangle here, that's going to represent your abatement, right? So with that in mind, we can go ahead and calculate this out. Our tax cost to the firm, or tax revenue earned by the government, is just 60 times 30, or the area of that rectangle, and that's going to be equal to 1,800. And then the abatement cost is going to be equal to the area of this triangle, that is 1/2 40 minus 30, which is the base of that triangle, times that 60, which is the height of the triangle, or 1/2 of 10 times 60, which is 300. Oop. Shouldn't have a comma there. It's not going to be 3,000, but just 300. And then our total pollution costs, or our total costs, I should say, to the firm, rather than our total pollution costs. We're not calculating that anymore. But our total cost is the tax cost that the firm's going to have to pay for having 30 emissions, plus the cost of abating those 10 emissions. So that's going to be equal to 2,100. Right. So that's the total cost to this firm under this tax policy. Right. So again, be able to do that for one firm, or be able to do that for multiple firms, should you have to do so. So we talked about how to calculate out the effluent tax and total cost for each firm in a case of multiple firms under this policy. So be able to figure out and graph the optimal tax as well as the optimal amount of emissions for each firm when the government wants to hold pollution to a certain level of emissions among multiple firms. All right, remember that involves setting the two MAC curves equal to one another, or the efficiency constraint, and then plugging in the abatement constraint, which is just the total pollution limit that the government is going to allow for both firms combined, right? And then just solve for the optimal number of emissions, right? Plug that into the respective marginal abatement cost curves to get the optimal tax rate, and then calculate the tax cost and abatement cost for each firm, just like we did for the individual firm in the last problem. Also, know what might happen if the government gets too involved in forcing companies to emit a certain amount of emissions in addition to taxing the amount emitted. So be able to calculate the total cost for each firm again and compare it to those previous total costs. So let's go through an example like that. So suppose that firms A and B have the following marginal abatement cost curves, and the government wants to use an effluent tax to keep emissions down to 30 units, right? So here are the three equations you're going to need to know. the marginal abatement cost curve for firm A, the marginal abatement cost curve for firm B, and then that constraint of how many total emissions the government wants to allow, which is just E sub A plus E sub B is equal to 30 if they want to keep that total number of emissions down to 30. So with that in mind, let's go ahead and go through this one here, both graphically and mathematically, starting out by setting up these graphs. All right, so again, we're going to have two graphs side by side here. That's where things get a little bit more complicated. I have two graphs looking something like this. Again, on each graph, we're going to have dollars on the vertical axis and emissions here on the horizontal axis, right? And then we're going to go ahead and draw out two marginal abatement cost curves, right? So we're probably going to have one that looks maybe something like this for firm A, and maybe one that looks something like this here for firm B. All right, so again, we can figure out where these marginal abatement cost curves are going to hit our Y's and X axes here, respectively. So again, if we set E equal to 0, we know that MAC sub A is equal to 120. And if we set MAC sub A equal to 0, right, then we know that E is equal to 120 divided by 3, which is 40. Right, so we know that this is going to hit right here at 120, and this is going to be 40. And we do the same thing for firm B, right? So if we set equal to 0, MAC sub B is equal to 280. And then if we set MAC sub B equal to 0, then we know that E is also equal to 40 here. So their maximum number of emissions happen to be the same. They don't always have to be, but in this case they are. All right, so we got 280 up there, right? All right, so again, that's kind of our initial setup, and we know that we want the optimal, or we know we want the total number of emissions allowed from both firms to be equal to 30. Right, so from there we've got to figure out one, what the tax is going to be, and then also what the optimal number of emissions are going to be for each firm. Right, so the way that we're going to do this, we're going to set MAC sub A equal to MAC sub B, so we're going to have 120 minus 3 E sub A equal to 280 minus 7 E sub B. It's important to note that using this equation, we know that E sub A is equal to 30 minus E sub B. And the reason why that's important is that we're going to plug this E sub A here into this equation's E sub A in order to get one equation with one unknown. So certainly nothing that we haven't done before, but just make sure you know that that's what's coming. So we got 120 minus 3 times 30 minus E sub B. It's going to be equal to 280 minus 7 E sub B. Right, so again, we can go ahead and calculate this out. So we got 120 minus 3 times 30, which is 90. We can take that negative 3 and multiply it by that negative E sub B. So make sure you distribute that negative sign through. That's going to be equal to 280 minus 7 E sub B. Now we can add that negative 7 E sub B from the right over to the left. Right, so that's going to give us 10 E sub B, and that's going to be equal to 280 minus that 30 from the left. We're going to subtract that over to the right, so it's going to be equal to 250. That means that E sub B star is going to be equal to 25, which means that we know that E sub A star is going to be equal to 30 minus 25, which is equal to 5. Right, now we need to figure out exactly where that's going to occur in terms of what tax is going to make those optimal number of emissions happen. Right, so we got MAC sub A at E star sub A equal to 5. So we're just plugging that 5 into our original MAC sub A equation. So it's going to be 120 minus 3 times 5, or 15. So it's going to be equal to 105. And then we got MAC sub B at E star sub B being equal to 25, right? So that's 280 minus 7 times 25, right? Which, if you do that math, is 280 minus 175, which is also 105. So again, it should be the same number if you did it right, and that number is going to represent the tax at which we're going to reach our optimal level of emissions, right? So that 105 here is our tax. Where it hits firm A here, that's going to be our 5, or E star sub A. Where it's going to hit firm B over here, that's going to be 25, or E star sub B. Right, again, this is our graph here for firm A. This is our graph here for firm B. Right, this is our marginal abatement cost curve for firm A. This is our marginal abatement cost for firm B. Make sure we get everything labeled. All right. So from there, you might have to figure out what is the total cost for both firms, right? So again, the total cost is just your tax cost plus your abatement cost, right? So go ahead and see if we can figure those out. So we'll call this here firm A. We'll do in red. So again, we need the tax cost for A plus the abatement for A is going to give us our total cost for firm A. Now remember, the tax cost is equal to the tax per emission multiplied by the number of emissions. Firm A is only having 5 emissions and has to pay $105 per emission. So that'd be 105 times 5 plus that abatement cost, right? And that's just this area of this triangle here. So again, that's 1/2. The base of that triangle is 40 minus 5, or 35, times the height of that triangle, which is 105. Right. If you calculate that out through, you should get a somewhat ugly number of 2,362.5. Sometimes when you come up with these examples, it's hard to make all the numbers pretty. With that in mind, then we need to do the same thing for firm B. We'll go ahead and do that one in blue. Right, so again, we got the tax of 105 times 25. So this is again the tax for firm B is $105 per emission times their 25 emissions plus the abatement for B, which is just going to be the area of this triangle here. That's going to represent their abatement costs. All right, and that abatement is 1/2 that 40 minus 25, so they only got rid of 15 emissions. But again, at $105 is the height of that triangle. All right, and so that's going to be equal to the total cost B here. Right, and so again, if you go through that math, you should get 3,412.5. All right, so again, not pretty numbers, but you see how to do it, hopefully. So with that in mind, again, be able to figure out what the abatement cost is, or the area of that triangle, what the tax cost is, or the area of that rectangle, add the two to get the total cost for both firms there. All right, now what happens if the government gets heavy-handed in terms of how they want to employ this policy? Let's say they say that no matter what, each firm has to have a total of 15 emissions. So in other words, we want both firms to have 15 emissions, and then we're going to charge them that tax of $105 per emission at 15, right? So if that's going to be the case, then as you're going to see, this is going to create a less efficient situation for both firms. So if we look back at the last slide, it says, know what might happen if the government gets too involved in forcing companies to emit a certain amount, for example, 15 units each. in addition to taxing the amount emitted at the same rate. So again, be able to calculate total cost for each firm again and compare it to the previous total cost. So let's go ahead and do that real quick to make sure that you understand how. So let's go ahead and use say purple here, right, for firm A. So let's say that the government sets the emissions for firm A equal to 15. So marginal abatement cost curve for firm A at E sub A equals 15 can be calculated out here using our marginal abatement cost curve. So we got 120 minus 3 times 15, or 120 minus 45 is equal to 75. So if we have 15 emissions, which might happen somewhere out here, again, this is the amount set by the government, that's going to hit your marginal abatement cost curve here at 75. All right, so from there we can figure out both our tax cost and our abatement cost for this firm, right? So again, we're going to figure out the tax for firm A plus the abatement for firm A, and that's going to give us our total cost for firm A. Right, so the tax cost is still the 105 times the number of emissions that they have, which in this case is 15. Right, in other words, our tax cost is now the area of this box here. Right, but then what's also going to be added to that, this abatement cost here, this is going to be 1/2 times the base of that triangle, which is 40 minus 15, times the height of that triangle, which is what we calculated there in the beginning at 75. And if we calculate that out, then you should get 2,512.5, which if you compare that to our original total cost for firm A, as you can see, is higher, right? So in other words, this firm here is now spending more money under this new policy than it was before. Now let's take a look at firm B, which we'll go ahead and do in green here. So again, taking a look at the marginal abatement cost for firm B at, now we got to set E sub B equal to 15. That's going to be equal to 280 minus 7 times 15, or that should be 280 minus 105, which is equal to 175. So at 15 here, you're going to have 175 as the cost of getting rid of that next unit of emission. And then same thing, you're going to figure out the tax for firm B plus the abatement cost for firm B. That should give you the total cost for firm B. All right, now the tax is again just the $105, which is our tax per emission, times the 15 emissions. Right, so again, your tax is just this box here. Right, but then you also need to add to that your abatement cost, which is now the area of this very big triangle right here. So that's equal to 1/2 of 40 minus 15 that we now need to multiply by 175. If you calculate that through, then you should get 3,762.5. Again, notice that that is higher than the 3,412.5 that we had originally. So when the government gets a little too heavy-handed here in terms of saying not only do you have to pay a tax per emission, but instead of you deciding how much you want to emit under this optimal effluent tax, we're going to decide for you how much we want you to emit and say split it equally versus allowing these firms to emit pollution at their optimal rate. Then what you're going to have is higher costs for both firms, but you're still not going to have a cleaner environment because both firms are still emitting 30 total units of pollution. Right? So in other words, our level of pollution hasn't changed. We just made it more expensive for these firms to comply with this policy. So again, setting a policy in place and allowing firms to optimize under that policy might be more efficient than you deciding what the firm should do under this policy, or the government deciding what the firm should do under this policy, as that could just increase their costs without making the environment necessarily cleaner. Right? So again, be able to do a question like that on the exam should you get one. With that in mind, let's go ahead and continue on and talk a little about those tradable pollution permits, which is the last kind of big math problem that we did for the class. So be able to calculate and graph the optimal amount of emissions for each firm, the permit trading price range, and the final permit selling price for each firm in a cap and trade system of tradable pollution permits. Right, once again, you're going to set the two MAC curves equal to one another using that efficiency constraint. Then you're going to substitute in that abatement constraint, which is the again the pollution limit that the government sets, right? And then solve for the optimal number of emissions, and then plug those initial emission allocations into your MAC equation for each firm in order to get the permit trading price range, right? And then plug in that respective optimal number of emissions into each MAC curve in order to get the final permit selling price. Right, and then from there, just understand who's buying and selling permits so that you can figure out the total cost for each firm. All right, so be able to do a problem like that on the exam should you get one. So with that in mind, says suppose that firms A and B have the following marginal abatement cost curves, and the government has set a pollution cap at 100 total permits and has allocated 50 permits for each firm. So again, be able to follow those instructions we just went through in order to figure out the total cost for each firm. Both before and after selling permits, and maybe even figure out how much money they save through these through buying and selling permits. Right, so that's the idea behind being able to do a problem like this. All right, so let's go through it. All right, so the optimal emissions under a cap and trade permit system using the problem that we just talked about is going to have these three equations. Again, your marginal abatement cost curve for firm A, your marginal abatement cost curve for firm B, and then your constraint of the 100 total emissions. Oops, didn't mean to do that. That we wanted for each for the total industry, right? So again, be able to optimize under these three equations here. So we're going to start as we normally do, and that is by drawing a graph. So we're going to have a vertical axis followed by a horizontal axis. And on the vertical axis, we're going to be measuring dollars. And on the horizontal axis, we're going to be measuring those emissions. Right, now, remember that we're going to be reading firm A from left to right on this graph in terms of their number of emissions. We're going to be reading firm B from right to left in terms of looking at their number of emissions. So you should do the colon over there. So with that in mind, that's kind of what this graph is going to be set up to look like. So let's start with our marginal abatement cost curve for firm A. It's going to look something like this. Again, downward sloping from left to right. So this is our MAC sub A. And we can tell exactly where that MAC sub A curve is going to hit the y-axis by setting E equal to 0, or maybe more appropriately setting E sub A equal to 0, where that MAC sub A is going to be equal to 400. So that's where that MAC sub A curve is going to be hitting that y-axis here. And then if we set MAC sub A equal to 0 and solve for E, then remember E is going to be equal to 400 divided by 4, or 100 here. Right, so again, we're going to read firm A's emissions from 0 to 100, which is the maximum number of emissions for firm B. Right, we can set MAC sub B equal to 0. And figure out that the maximum number of emissions for firm B is also equal to 100. So again, we're going to be reading it from 0 to 100 here for firm B, again from right to left. Right. And again, that MAC curve for MAC sub B curve is going to look something like this for firm B. This is MAC sub B. All right. So with that in mind, remember that there is a constraint here that both firms have to operate under at a limit of 100. Right. So E sub A is equal to 100 minus E sub B. So with that in mind, we can go ahead and start to calculate out an equilibrium or get the optimal number of emissions for each firm, as well as what that last permit price is going to be. Right, so as we are calculating this out, right, again, just setting MAC sub A equal to MAC sub B. Right, so we got 400 minus 4 E sub A equal to 100 minus E sub B. And E sub A here is what we're going to be plugging into this equation. So that 100 minus E sub B is what we're plugging in there. So it's going to be 400 minus 4 times 100 minus E sub B equal to 100 minus E sub B. So 400 minus 4 times 100 is 400, and negative 4 times a negative E sub B is equal to a positive 4 E sub B. That's going to be equal to 100 minus E sub B. All right, so we're going to get our E sub B's together, right? So bring that negative E sub B over to the left side. So we got 5 E sub B. E and those 400s are going to cancel. So E sub B is going to be equal to 100. So we know that E sub B star is going to be equal to 20, which means that we know that E sub A star is equal to 100 minus 20, which is going to be equal to 80. All right, so again, firm A here's optimal number of emissions is here at 80, whereas firm B is at 20. Now, with that in mind, we can go ahead and figure out, again, the last permit price that final permit is going to be bought and sold for. It's just that equilibrium there by plugging our E sub A star into our MAC sub A equation. And we can do the same thing for E sub B star, plug that into our MAC sub B equation. Right? And again, you should get the same number if you did it correctly. So MAC sub A, this is going to be at E sub A star being equal to 80 here. It's going to be equal to 400 minus 4 times 80, or 400 minus 320 is equal to 80. And then MAC sub B at E sub B star equals 20 is going to give us 100 minus 20 also equal to 80, right? All right, so with that in mind, that's not where the firms start. However, remember, each firm is given 50 permits, and so with that in mind, that is where these firms are going to begin the process here. Right, so 50 will occur somewhere halfway between 0 and 100, so we'll say right around here. Right, so we need to figure out where that 50 is going to hit each of these respective marginal abatement cost curves. Right, so in order to do that, all we got to do is plug 50 into those marginal abatement cost curves. Right, so MAC sub A at 50 MAC sub A at E sub A equals 50 is just 400 minus 4 times 50, or 400 minus 200 is 200. So that's going to be plugged in there. And then MAC sub B at E sub B equals 50 is going to be equal to 100 minus 50. That gives us 50. So we're going to plug that in there. And this right here represents the trading range for these two firms. Right. So we know that this trading range is between 50 and 200, and that the final permit selling price is going to be $80. Right. Now, with that in mind, we know that firm A is going to be willing to buy permits from firm B. Right, and we know that because firm A there is having these higher marginal abatement costs, or it's a higher cost for them to get rid of emissions, right? If they get a permit for less than 200, then it makes sense for them to buy it. Whereas firm B, if they can sell a permit for more than 50, then it makes sense for them to sell it, right? So again, just to make sure that we're clear on what we're calculating here, or what is happening here, the trading range is between 50 and 200, and that final selling price is equal to 80, right? With that in mind, again, firm A is going to be buying 30 permits from firm B. Now, again, if you want to figure out who is buying and who is selling, look at what's happening before permits are being traded, right? They each start with 50, right? But firm A ends up moving from 50 up to 80 emissions, which means they had to acquire 30 permits. Firm B is going from having 50 emissions down to 20 emissions, right? That means that they are going to be selling those 30 permits, right? So that's kind of how you can figure out who is buying and who is selling. So the last thing we need to do is figure out the costs for firm A, both before and after trade, as well as the cost for firm B, both before and after trade, to see how much they save by buying and selling permits. So we'll start out with firm A. We'll go ahead and do them in red here. So we'll start out with firm A here before trade. And so to look at firm A before trade, then we just need to figure out what is their abatement cost before they are out there trading permits, which is basically the area under their marginal abatement cost curve at 50 permits, right? So in other words, when you're looking at this abatement cost here for firm A, this is the area that you're looking at here. So before trade, it is 1/2 of 100 minus 50 times that height of that triangle, which is 200. So they're getting rid of 50 permits, or sorry, 50 emissions, and again, 200 is that height of that triangle, right? So that's 1/2 of 50 times 200, which is equal to 5,000. Now, if we want to take a look at what happens to their cost after trade, we'll go ahead and do that in blue here. Then you got to look at both their abatement costs as well as the price that they are paying for these permits, right? So after trade, it's just abatement cost. And because firm A is the one buying these permits, right, you have to factor in the cost of buying these permits from firm B. So that is the permit cost. All right, so the abatement cost is just now the area of the triangle when they are having 80 emissions. In other words, their abatement cost is going to go down to that triangle there. So that's going to be equal to 1/2 100 minus 80, or 20 is the base of that triangle. So getting rid of those 20 emissions, right? And that's multiplied by the height of that triangle, which is 80, right? Plus the permit cost. Now remember, they are buying 30 permits, and assume that they're buying them all at the final selling price of $80 per permit. It says plus 30 times 80, right? So if you went ahead and calculated this out through, this is 1/2 of 20 times 80, or 1/2 of 1600, which is 800, plus the 30 times 80, which is 2,400. So that's going to be equal to a total of 3,200, which is less than the 5,000, which was the cost before they traded permits. So in other words, when it comes to firm A, they are saving $1,800 here through this permit trade. All right, So let's take a look at firm B. We'll start them off in green here. Both before and after trade. So before trade, firm B, again, you have to look at the area of the triangle that represents the area under their marginal abatement cost curve when they are at 50 emissions, right? So in other words, this would be the triangle you're looking for here when trying to figure out their cost before trading, right? So that's going to be equal to 1/2. The base of that triangle is 100 minus 50. Again, they're getting rid of 50 emissions in compliance with the law when they get those 50 permits, right? Then that's 50 emissions they have to get rid of the 100 that they would be polluting if there were no laws in place, right? And then that's multiplied by the height of that triangle, which is that 50. Right, so that's 100, or sorry, that's 1/2 times 100 minus 50 times 50, or 1/2 of 2,500, which is 1,250. Now, if you want to look at their after trade, then do this in purple. Right, then again, we've got to figure out the both abatement costs and the permit revenue. So they're going to be abating more emissions, so their abatement costs are going to go up because they're selling some permits, but we get to subtract from that cost the amount of money that they would be making in permit revenue here from selling those permits, right? So the abatement costs are going to be the area under the marginal abatement cost curve that occurs when they are operating at those 20 emissions. So in other words, it's going to be this area of just triangle here, right? So it's going to be 1/2 of 100 minus 20. Notice that they have to abate 80 emissions now instead of 50 because they sold 30 of those permits, right? Times the height of that triangle, which is 80. Subtract from that their permit revenue, which is again the 30 permits that they're selling at the final permit price of $80 per permit. And again, go ahead and assume when I do these kinds of problems that they are always buying and selling at that final permit price, right? So again, this is going to be 3,200 minus 2,400, or a total of 800 is going to be the after trade cost for firm B. Now remember that before they traded, the cost was $1,250. So in other words, this firm is going to save $450 by abating some more emissions and then selling off those permits, right? So again, both firms win here, or both firms save through the buying and selling of these tradable pollution permits, right? Which is why economists tend to enjoy a policy like this, right? Again, it kind of makes sure that the emissions are coming from the firms who need to emit the most, and again, the kind of rewards the cleaner firms, right? Because they receive money from their competitors. So firm B, the cleaner firm here, gets more money from firm A. Firm A has to pay money to its competitor for firm B there in order to acquire those permits. Right. Now, one of the things that we did talk about in class was understand the costs and benefits of the different ways that the government can allocate permits. So remember, you can give permits to the firms with the higher abatement costs. Unfortunately, this does reward the least environmentally friendly firms. So while it's the most efficient in terms of reducing costs, it does create some perverse incentives of incentivizing firms to become less environmentally friendly. Now, you give permits to the newest firms in the industry. Unfortunately, these newest firms are usually the ones who have adopted the most cleanest technology, and so they're firms who need it the least. So this won't minimize costs, but this will again reward new firms that are more environmentally friendly. Or now you could also allocate permits through auctions. That might be the fairest way to do it. Unfortunately, this also allows for the possibility of bigger firms to dominate smaller ones, right? So again, each way that you allocate permits could have some potential costs or benefits associated with it, right? So kind of be familiar with those for the exam. All right, moving forward in Chapter 7, know how to read the fishery graph that we went through in class, right? Please make sure you know why the population growth rate is shaped the way that it is. Or remember that at small amounts of fish, population growth is small, because even though there's plenty of food and space, the amount of mates are scarce, or amount of potential mates are scarce. At medium levels of fish population, the growth rate tends to be higher because there's plenty of food and space still. There's also plenty of fish to mate with. And then at high rates of fish population, the growth rates tend to be smaller again, right? Because now, even though there's plenty of mates around, there's not as much food or space available, and also these high quantities of fish might attract predators. So be familiar with why that population growth rate is shaped the way that it is. Know which rate of removal will give us the maximum sustainable yield. Know which level of effort will maximize profits for fishermen. Remember, that's where marginal cost intersects marginal revenue, or is equal to marginal revenue. Know which level of effort will result in the fishing market reaching a long-run equilibrium. That's where our total revenue is equal to our total cost, or the profit of each firm in the industry is equal to zero. And then understand the decision-making process in the fishing industry as to when effort would be increased or decreased. Basically, if economic profits are positive, fishing boats will enter the industry and drive those profits down towards zero. If you're making economic losses or negative profits, fishing boats will leave the industry, again, until there are zero economic profits. So remember, zero economic profit is that long-run equilibrium. Right, so if I give you a graph like this one, right, be able to tell me again which removal rate represents the maximum sustainable yield, which effort rate maximizes profits for a particular fisherman, and then which effort rate or removal rate might give us that zero economic profit in the long run, or that long run equilibrium. Right, so just make sure that we can do that real quickly. Let me go ahead and step out of the full screen mode. Right, so if I were to ask you what represents the maximum sustainable yield, remember, the maximum sustainable yield is the most that you can remove and still have those fish be able to replenish in the future. And that's where your removal rate is equal to your growth rate at the highest removal rate possible. Or in other words, the removal rate that will give you the maximum sustainable yield would be R3. All right, again, this point right here is the most that we can remove, right, and still have that fish replenished in the future. Now, if I were to ask you what would maximize the profits, so the profit maximizing effort, we'll do that in blue. And again, you want to follow the rule here where marginal revenue is equal to marginal cost, right? Remember, that is the profit maximizing rule that we talked about in that microeconomic review of chapter 3. And that happens where the slope of the total revenue curve is equal to the slope of the total cost curve, or you have a tangent line just touching that total revenue curve that is parallel to that total cost curve, which happens right here. So if I asked you for the level of effort, that would be E2. If I asked you for the removal rate that maximizes profits, that would be R2. Right? All right, now if I were to ask you what level of effort would give us a long-run equilibrium in the fishing market, again, you need to know that that's where total revenue is going to be equal to total cost, so that our economic profit is equal to zero. So our total cost curve and our total revenue curve intersect right here at 0.5. So if I ask you for the level of effort that makes that happen, that would be E5. If I ask you for the removal rate that makes that happen, that would be R1. Right. So again, be able to look at a graph like this and answer questions like this on the test. Should I give you that graph? I'm not going to ask you to draw this graph out for the exam, especially with you all taking it online, right? But I might give you this graph and then ask you these 3 questions. So be able to answer those questions, right? So again, be able to say what the maximum sustainable yield is, know where the profit maximizing effort occurs, and know where the long run equilibrium occurs in this fishery graph, right? So again, just be able to follow the rules. Profit maximization is where marginal revenue equals marginal cost. Long run equilibrium is where total revenue is equal to total cost. Okay. Moving forward, also know when you should cut down a tree to maximize your rate of return from that tree based on the market value, the market rate of interest, and the growth rate of the tree. All right, remember that if the interest rate is higher than the growth rate, then you probably want to cut that tree down today and invest that money. If the growth rate is higher than the interest rate and that tree is still growing, you might want to wait until next year to cut down that tree and then sell that lumber that you get from it then. And then know the myths and truths about clear cutting. Clear cutting is the myth is that clear cutting is about harvesting trees at the expense of the environment, whereas the truth is the principal objective of clear cutting is to regenerate the forest with healthier trees, not to harvest timber. If you want to harvest timber to maximize your profit, then again you would do what's called diameter select limit cutting or high grading, where you take only the straightest, biggest, most profitable trees, and you leave the ugly trees left that won't net you as much money, but that won't replenish the environment as well, particularly if it's a species that requires a lot of sunlight. Another myth about clear cutting is that it causes soil erosion. Remember, clear cutting does not cause soil erosion, but poorly laid out road systems created by loggers will. So as long as they lay out those roads according to their best management practices or BMPs, then again they won't cause that soil erosion. So as long as they're following the rules and regulations, then you can clear cut without causing the soil erosion to happen. Another myth is that logging companies prefer clear cutting because it's the most economical way to harvest timber, whereas the truth is many logging companies dislike clear cutting because it forces them to spend time and money cutting down trees that they have no use for. Right? Remember that if you're a logging company, you prefer that high grading. That's how you're going to maximize those profits, right? But if you have a timber stand on your property and you care about the future profitability of that timber stand, you might tell that company, if you want this wood, you got to clear cut it. Another myth is that clear cutting destroys animals' natural habitat, whereas in truth, clear cutting can be very beneficial to wildlife by increasing the biological diversity of the forest. Remember, when you clear cut, it allows room for a lot of shrubs and bushes and things like that to grow that's going to attract wildlife. But we took a look at several species of birds, like the common yellow throat and the prairie warbler, and we saw how those numbers of species increase with clear cuts more than just leaving the woods alone or any other types of cut. All right, so know the difference between clear cutting, shelter wood cutting, and diameter limit cutting, and the cost and benefits of each. Right, so remember, clear cutting is something you should do if you have a shade intolerant species of trees, so one that prefers sunlight. You also care about the future growth more than the current income, and you don't care about the current aesthetic value of your property. Remember, the cost of clear cutting is that it's not as much income as you can make now, and it is somewhat unsightly to have this big clear patch in your timber stand. Shelter wood cutting might be more appropriate if you have a shade tolerant species of tree and you care more about the future growth than you do about current income, right? And if you do care about the aesthetic value of your property, you might want to practice that shelter wood cutting. Diameter limit cutting or high grading involves caring a lot more about current income than future growth. Remember, that's the one that will get you the most money now. However, it is the one that will lead to the least replenishment and probably the lower value of your timber stand in the future. So again, know under which conditions you might want to, say, practice clear cutting, shelter wood cutting, or diameter limit cutting, right? Like if you were about to move from your piece of property and you want to make some money before you did, that's when you might want to think about clear cutting as, if you're about to move, you might want to think about using high grading, right? Because that's going to get you the most income now, right? And it's not going to necessarily make your property look worse for when you go to sell it to potential buyers. Right now, if you were going to be on your property for a long period of time, that's when you might want to engage in clear cutting, right? Because again, you're going to reap the future benefit of that forest rejuvenation. All right, and then chapter 8, our final chapter, know the process of commercial agriculture and how that leads to genetically modified organisms. Remember that with commercial agriculture, you tend to plant crops in these long rows that covers large acres, and then you tend to cover those crops with a fertilizer, a chemical fertilizer that will make them grow into big nitrogen-rich plants, which attract a lot of pesticides. So then you have to cover them with attract a lot of insects. So you got to cover the plants with pesticides, and then you have to cover the plants again with herbicides, right? And that can all destroy the plants. So then you have to grow these genetically modified crops that are resistant to insecticides and herbicides. These genetically modified crops or food are also more tolerant to heat, cold, and drought, and have higher crop yields, right? And have saved a lot of lives from starvation, particularly in developing countries, by providing a lot more food more cheaply so that people in those countries can afford them also reducing the risk of harvests being destroyed by, again, either bugs or extreme temperatures or drought or anything like that. And again, in some of these places, if your harvest gets destroyed, that's pretty much the end of you. You don't really have any backup or bumper crop to survive on. Right. Now, there are some costs to genetically modified crops and food. Right. Remember, one is a possible increase in allergies. Right. Now, that's proven to not necessarily be true. It doesn't increase food allergies. However, you can increase allergic reactions to food if a food that you're not allergic to is spliced with a food that you are allergic to. That's why there are certain regulations in terms of what you are allowed to or what you have to show or identify in terms of if foods do cause allergic reactions, right? So remember, there are certain regulations you have to adhere to, right, when you're producing a genetically modified organism or crop, right, to show whether or not it's going to cause allergies and to notify the public of those potential allergies. Now, another fear is that could possibly create a resistance to antibiotics. So far, that hasn't been proven to be true, although, again, these genetically modified crops are fairly new. We're only about 25 years into using them, so it's hard to say what might happen in the future. And another one is a possible increase in cancer rates. Remember, that was based off a study using these lab rats. However, the sample size wasn't that big, and the rats that were used had a predisposition to getting cancer anyway, right? So again, it's not necessarily the case that it will increase cancer. It's just suggested by a study that might be flawed, right? So with that in mind, remember the American Cancer Society says it's kind of on the fence about what GMOs could do to cancer rates, and so more research is needed there. So all these are potential costs, none of which have necessarily been proven, or each has, again, a kind of a mitigating factor associated with it. So definitely something to keep our eye on, but maybe we shouldn't necessarily be protesting genetically modified crops yet until all the research is in. Again, it's been said that GMOs have saved more lives, or has been the human innovation that has saved more lives than anything else, next to maybe the smallpox vaccine and antibiotics. Right, so next to those medical innovations and maybe fire, GMOs is probably the next greatest human innovation, according to some scientists. Right, so now the costs and benefits of commercial agriculture. Remember, some of the benefits of commercial agriculture includes the fact that it grows a lot of food more quickly and easily, which lowers the price of food and makes it more affordable, again, especially for developing countries. And then competitive pressure in the commercial agriculture industry has led to a lot of innovations that allowed us to feed much of the world's growing population with a lot less work, right? Remember that the food production is now a very capital-intensive industry, so we need far fewer man-hours to produce the kind of food necessary to feed the 7+ billion people in the world, a population that is growing and growing exponentially. Some of the costs of commercial agriculture includes the fact that its capital intensity means that there are high startup costs, which is difficult for the poor to compete in the market. Farming used to be something that the poor could do to earn a living. Right, it's getting harder and harder for the poor to compete with big agribusiness. It also doesn't employ nearly as many people as agriculture used to, and that involves people having maybe lost a connection with their food or not really understanding the kind of effort, time, or money it takes to producing food. So that gives us kind of a more wasteful nature when it comes to using food. Right, a lot of us throw out food every week and don't think anything of it. If we had a greater appreciation for what it took to produce food, maybe we wouldn't do that as much. And as we talked about, there could be some potentially negative health and environmental side effects of commercial agricultural production methods, in addition to the potential negative health effects of GMOs that we talked about. Remember that all this pesticide and herbicide could create some chemical runoff that could pollute nearby waters and streams, and also could degrade the value of the land. Right. With that in mind, there is an alternative called permaculture. So know the principles and practices of permaculture that we talked about in class. Right, one of which is catch and store energy. You could do that through solar power, or you could do that through the 3 S's of managing water. Remember, you want to slow it down, spread it out, and sink it in, particularly if you are in a tropical climate. Remember that you want to organize the system, designing from patterns down to details. Right, be able to give an example on efficient design from the Thailand permaculture site discussed in class. That could be having the catfish pond next to the hen house so that you can just sweep the excrement from the hen house into the catfish pond. Since catfish are bottom feeders, it's a way to feed your catfish with the waste from the hen house. So again, nothing really goes to waste there. Could be having the duck pond near the lime trees because limes attract slugs and ducks like to eat slugs. And then when ducks walk around, they aerate the soil. And when they defecate, they fertilize the soil. It could be planting the banana trees around the duck pond to keep the water from the pond from evaporating because banana trees provide a lot of shade, right? Or it could be planting the coconut trees near the banana trees, right? Because again, banana trees tend to produce a lot of water and potassium, and coconut trees tend to consume a lot of water and potassium. And that leads us to number 3, integration, not segregation. Understand the idea of companion planting and crop synergies and be able to give an example. We talked about planting tomato next to basil because the tomato plants provide shade for the basil while the basil keeps the bugs away from the tomatoes, and both improve their flavor, each other's flavor, while competing over different nutrients from the soil. Or again, you could reference the reason why coconut trees are planted next to banana trees. Then the 4th principle we talked about in class was produce no waste. Or be able to get examples of this from the permaculture farm that mentioned in Thailand. We talked about biochar or burning burning carbon heavy material like corn husks or rice husks or things like that, right? And then using that as a fertilizer. Fermentation, again, you throw some coconut leaves and weeds and a little bit of sugar into a barrel full of water, cover it and let it ferment. And that's going to create, again, something that you can use to help increase the productivity of your soil. And then worm castings, which are big basins full of pig manure that you put worms in. As the worms work their way through it, they kind of recycle the nutrients and the soil there in that manure, and then you just pour water into it and drain it from the bottom, and that's a nutrient-rich water you can use to fertilize your crops. Right. So again, make sure you understand kind of what that permaculture system or idea involves. Then the costs and benefits of permaculture. Right, the cost of permaculture is that it's very labor intensive with very high fixed costs in the beginning. It takes a lot of manual effort to set it up, and therefore it's not ideally suited for large pieces of arable land. However, if you do set it up properly, some of the benefits of permaculture includes the fact that the system is largely designed to manage itself. So once you have it set up, right, again, it kind of relies on nature's natural principles to run itself. So all you got to do is go through, make sure that there aren't any issues, right, and just pick the fruit and vegetables that are growing. And then as a small piece of, through permaculture, you can use a small piece of land to produce a variety of organically grown food in a sustainable manner, right? So even if you had a piece of land with maybe a quarter or half acre, which is affordable even here in Southern California, right, then you might be able to grow your own organic fruits and vegetables. And then finally, know how to make your own compost using the Berkeley 18-day compost method. Remember that involves layering brown matter, green matter, and high nitrogen, right? Brown matter is that carbon-heavy material. It could include things like cardboard or cut-up cloth, right, as well as like things like leaves, right? Remember, green matter is stuff like grass clippings and food scraps, and then high nitrogen refers to urine, manure, or dead stuff like dead animals, maybe like dead lizards or mice or birds that your pets bring to you, right? So you just keep layering brown, green, and high nitrogen, starting with brown and topping it off with brown, right? And remember that you want to keep it between 140 and 160 degrees. If it is below 140, you need to heat it up with some high nitrogen. If it is above 160, you need to cool it down with some more brown matter, right? And after 18 days, you should have a nice compost pile that you can use to fertilize your crops. Right. Again, sometimes it takes a little bit longer depending on how well you do it. It's about 18 to 30 days, but 18 is about as quick as it can happen. Right. So with that in mind, that is it for Chapter 8. Right. And that is it for this review session. Hopefully you found it useful. Just let me know if you have any questions. You can shoot me an email and visit me during those Zoom office hours, and I'll be happy to answer any questions you may have. Right. Again, if you're looking to review the old material, you want to look at that midterm exam review session. That'll cover chapters 1 through 4. All of them, chapters 1 through 8, are going to be covered on the exam. So it might be useful for you to go back through that old material as well as this review here. Right. And other than that, happy studying. Good luck. I'm confident if you study hard, you will do well on the test. But again, just let me know if you need anything in the meantime. Take care.